Hello students, welcome back once again to my YouTube class. Hope all of you are fine today. Students, today we are going to discuss chapter 15, magnetism. You might have seen a magnet, how it looks and how does it works. We know these magnets are of different shapes, size, and its only property is to attract magnetic substances. We might have seen a bar magnet. A bar magnet, it looks somewhat like this, rectangular shaped, having a long bar. Okay, such a magnet can be called as a bar magnet. You might also have seen a magnet of such a type. It is called a horseshoe magnet, or you might also have seen a magnet available in such a shape which is called a disc shaped magnet. So different types of magnet we find depending on their sizes or shapes. So all the magnets, whatever it is, whether it is a bar magnet or a horseshoe magnet or a disc shaped magnet, all magnets have the same property. Their only property is to attract magnetic substances. So my dear students, in this chapter we are going to learn how these magnets have existed, or the mysterious ways on the existence of this magnet. In olden days, people at the time when they happened to travel from one place to other place, they didn't have any transportation system, and they used to go on traveling using some cattle or sometimes by walking. So while traveling, they are in a need to find the direction or the way that they need to travel. So when they have to follow the way, or when they need to find out the direction for the way, at that time they were using a stone which is known as iodostone, or this iodostone is the stone, okay, which has got its name because it's the stone which helps them to show the way, or we can say stone way. Okay, so this iodostone has also got another name, that is the magnetite. The travelers, they were using the magnetite rock for finding their way, as it helps them to show the direction. Okay, so the ancient Greeks called the rock as magnetite, and after the province of Magnesia, where it was found, now we came to know that the magnetite is a magnetic ore of iron. Okay, but it's not an ore of magnetite, is no more an ore of magnet. Okay, but before the province of Magnesia, these magnetite rocks in olden days by the Greek travelers and all, okay, they have given the name magnetite, and they were using it to find their directions. So let us learn some other properties of a magnet. I have already told you that magnet has got only one property, that is it helps to attract magnetic substances. Magnetite is a natural substance or natural magnet, while magnets you see around you are made artificially from a variety of metal. Okay, this magnetite, we know that is the natural magnet which were discovered by the ancient travelers. Okay, for at the time when they were traveling, and they use it for finding their way. And if we talk about at present, we know that there are many different types of magnet. If we look around, we see, and all these magnets that we see at present, these are all magnets which are made artificially. Okay, from a variety of materials. They come in various shapes and sizes. The most common one is the bar magnet. I have shown you how a bar magnet looks like. A horseshoe magnet is made from a bar bent in the shape. So how this horseshoe magnet is made? It is made in the shape of U, yes or not? So this horseshoe magnet is made by bending a bar magnet. Okay, magnets in the shapes of rods, discs and rings are also available. You can get magnets from a store for scientific supplies or a toy shop and explore their properties. The magnets where we are talking about are called permanent magnets. So whatever magnets so far I have said, okay, these are all magnets, okay, which has permanent magnetism power, or they are also called permanent magnets, because such magnets do not lose their properties unless they are severely damaged. Okay, all those magnets, okay, which you have been using it in your homes or which you have it, the magnets, as they are called permanent magnets, they hardly lose their magnetism, okay, unless they are severely damaged. So now we are going to learn some other properties of magnets. That is, magnets attract certain substances. We know that if you bring a magnet and nearby the magnet, if you bring some magnetic substances like iron particles or pins and all, okay, so what happens is that these iron particles gets attracted to the magnet. So we are able to understand that magnets attract iron particles. So all the substances that gets attracted to a magnet, these are known as magnetic substances. So only the magnetic substances are attracted by a magnet, like iron, nickel, cobalt, aluminium. We know all these are the substances which are easily attracted by a magnet. You might have heard the name Alnico. This Alnico is an alloy, okay, is an alloy which is considered as a permanent magnet, and it is made out of aluminium, nickel and cobalt. So these elements, aluminium, nickel and cobalt, these are some of the elements which we always use it for making a permanent magnet. So iron, nickel and cobalt, these are also the three elements which are always used for preparing a permanent magnet. And amongst all the permanent magnets, we consider this Alnico as the strongest magnet. Why? Because this magnet, okay, consists of elements like aluminium, nickel and cobalt, and it hardly loses its magnetism. We know, students, that all the magnets, whatever we have it at present, okay, these are all artificial magnets, and if we go on using all these magnets, we are able to find some changes in each and every magnets. It has got differences in shapes, sizes and properties also. Okay, depending on the power or magnetic power, okay, a magnet will attract things. So this Alnico is an alloy of aluminium, nickel and cobalt, okay, which is the most powerful permanent magnet. You can make a permanent magnet by yourself also. If you want it, you can make it by yourself. You simply need to have a magnet and a alloy. Like steel, you know that steel is an alloy, okay, which consists of a mixture of metals and non-metals. So this steel, taking a steel pin, or you can say steel nail, or sometimes you might have seen the needles are available in steel, okay, so you can take a steel needle and a magnet, okay. So taking these two items, what you need to do is that you need to take the magnet on the top of the steel needle. So consider this as a steel needle and take a bar magnet on the top of the steel needle and stroke it for 20 to 30 times in such a direction. once going this way and then again going backwards. In this way, you stroke the magnet on the steel needle for 20 to 30 times. After that, you try to attract some pins or some iron nails. What you will see is that this needle which you have struck it with a magnet will also act like a magnet. So by doing such activities, you can also prepare a permanent magnet. And there are some magnets, okay, which loses its magnetism very short time, within a very short time, and such magnets we call it as temporary magnets. So what are temporary magnets? Those magnets which loses its magnetism within a short time. Okay, these are temporary magnets. So how can you prepare a temporary magnet? If you bring a magnet nearby some pins, okay, nearby some pins, first of all you take one pin and try to bring the magnet in contact with a pin. What will happen? You will find that the single pin which you have taken it in your finger will get attracted. Then in the second step, again you take one more pin and take it nearby the pin that has attracted. You will see one by one a chain will be formed. Yes, a chain will be formed. All the pins will get attracted to each other in a chain, as you can see in the picture that is given in figure 15.3. So we can see a chain of temporary magnets which is formed because of the only magnet which has got attracted to one pin. Now if you remove the magnet from the chain of pins, what will happen? All the pins will get separated again. That means all the pins will lose their magnetism. So such a magnet can be called as a temporary magnet, and we can prepare it very easily. So you can do such funs at home by playing with a magnet, by doing such activities. Now students, we are going to learn some other things, some other topics. So the topic that I am going to start now is magnetic poles. Magnetic poles. You know that all the magnets have got poles which are called as North Pole and South Pole. So the poles of the magnet are always found on either sides of the magnet. In case of a bar magnet, you can see that in one pole end of the or at one side of the magnet you can see a North Pole, and on the other side you can see a South Pole. So likewise, all magnets have got poles on either sides or ends of the magnet. So these poles are also considered as the part of the magnet which has got more magnetic power. That means most of the magnetic substances gets attracted to the poles of the magnet. We are able to find some of the magnetic substances getting attracted to other parts of the magnet, but mostly we find the magnetic substances getting attracted only to the poles of the magnet. That is why the magnet seems to be the strongest at 2 points, okay, which are called as the poles of the magnet. If you try to suspend a bar magnet, one of its pole always points towards the geographical north, and this pole is called the north-seeking point. So try to suspend a bar magnet. This is a bar magnet, you can see on the board. So when you try to suspend by tying a thread on a bar magnet, consider this as a bar magnet, and you tie one thread at the center of the bar magnet. What you will find is that the bar magnet has got two poles, and you can see one end of the pole in the bar magnet, which is called as the north pole. Okay, it will always point towards the geographical north direction, so it is also called as the north seeking point. As it always points towards the geographical north direction, it is called north seeking point, and the south pole of the bar magnet will always point towards the geographical south, so it is called as the south seeking point. So at the time we have learnt, when the ancient travelers happened to travel, they were using a magnetite stone. So this magnetite stone was called as iodized stone, and it has been used to find the way, so it is also called as way stone. So we can easily determine that using a bar magnet we are also able to determine the direction of the place. Now we are going to another topic, that is the magnetic compass. Magnetic compass were in use to us at present, but in olden days these magnetic compass were not discovered, so we were using these magnetite stones and all. But now, as we have got this magnetic compass, okay, using this magnetic compass we are able to find the direction at the time of traveling very easily. It's a device, okay, which is very simple, and it always helps to find the direction. It consists of a magnetic needle that can turn freely, okay, about its center, and the needle that is encased in a box with a transparent top, and the directions that we find is inside the compass. These are printed or cut placed below the needle, and the needle of the compass is marked on top of the box, okay, with some colors of blue or red. When we keep away the magnetic compass from any magnetic substances, what happens is that we find that this magnetic needle, okay, always points towards the geographical north. As we know that the magnetic needle which always points towards the geographical north, it is painted with red or blue color inside the magnetic compass. So if we keep the magnetic compass away from any magnetic substances, what will happen is that the needle of the magnetic compass will always point towards the geographical north, okay, and the south pole of the magnetic compass, that is south needle of the magnetic compass, will point towards the geographical south. So my students, you might be getting confused why the south pole of the magnetic needle of the compass always points towards the geographical south, and why the north pole of the magnetic compass, needle of the magnetic compass, points towards the geographical needle. We know that our earth also has got a huge bar magnet inside it, which is invisible to our eyes, which we are not able to see at all. So when I will go forward discussing each and every topics, it will be getting clear to you. So let us discuss how this magnetic needle gets deflected at the time when we bring a magnetic substance nearby a magnetic compass. If we bring a magnetic substance nearby a magnetic compass, what will happen? The needle of the magnetic compass gets deflected. It gets deflected and it changes its direction. Okay. Nextly, we are going to learn the interaction between magnetic poles. We have learned that all the magnets has got poles, and the poles of the magnet are the strongest part of the magnet, which helps in attracting magnetic substances. Okay, we know that if we bring two bar magnets togetherly, okay, and bring it close to each other, we find that in some cases the magnet gets attracted, and in some cases we find that magnet gets repelled. For example, you have brought two bar magnets. Okay, so you consider this pole as the north pole and this pole as the south pole. Here this pole as the north pole and this pole as the south pole. So as you have brought two bar magnets, in this case what will happen? Can you say whether it attracts or not? In this case we see that these are the two poles, this as the north, this as the south, and this as the north and this as the south. So here what will happen is that these two poles are opposite to each other. So when the poles of the magnet, okay, are found in opposite nature, the magnets will always show attraction. So here in this case we can see that the magnet gets attracted. So at the time when we find that the poles of the magnet are unlike, that means the poles of the magnet are not different, they are same. Suppose this pole as the north and this pole as the south. In this case what will happen is that as the poles of the magnet are like, they are same, the magnet will no more attract each other. It will always show repulsion. That means it will get separated, it will get repelled. So these are the interaction that takes place between the magnetic poles. If the poles are unlike, it will show repulsion, and if the poles are like, it will always show, if the poles are like, it will show repulsion, and if the poles are unlike, that means the poles are different, it will always show attraction. Now we are going to discuss another topic, the earth of a magnet. Students, just few minutes before I have said you that our earth has got a huge magnet inside it which is invisible to us. And why the compass, the needle in the compass always points towards the geographical north and the geographical south, and we are able to find the direction very comfortably using this magnetic compass. Okay, so it is only because if we go on doing some certain activities, like you bring a magnetic compass, and by bringing a magnetic compass what you need to do is that you need to bring a bar magnet. When you place a bar magnet on top of a magnetic compass, matching the north pole of the bar magnet with the north pole of the magnetic needle inside the compass, and the south pole of the magnetic needle of the compass with the south pole of the bar magnet. If you keep it in matching, what will happen? It will not show any changes. So what you need to do is that you have to keep it, the bar magnet, the north pole with the south pole of the magnetic compass and the south pole with the north pole of the magnetic compass, and you place it and try to rotate the bar magnet. What will happen? You will be able to find some deflections. You will be able to find the deflection of the magnetic needle, and the point where you stop the bar magnet, at that point what will happen? The needle of the magnetic compass will also stop pointing the north with the south of the bar magnet, the north pole of the magnetic compass, okay, magnetic needle of the compass with the south pole of the bar magnet, and the south pole of the magnetic needle of the compass, okay, with the north pole of the bar magnet. So from this activity we can understand one thing, that the earth, which has got a huge bar magnet which is quite which is invisible to our eyes, okay, it also keeps every magnetic substances, okay, by attracting towards its opposite poles. Okay, that is why we are able to determine that the Earth also has got a huge bar magnet inside it. That is why the North Pole of the magnetic compass always points towards the geographical north, and the South Pole of the magnetic compass always points towards the geographical south. So now let me show you consider this as the bar magnet which is found inside the Earth, which is invisible to our eyes. So whenever we happen to bring any whenever we happen to use a magnetic compass, when we bring it or when we stand in any place of the Earth, we always find that the North Pole of the magnetic needle of the compass will be pointing towards the south of the Earth compass. Okay, and the South Pole of the magnetic needle compass, okay, will point towards the north of the Earth compass. So in this way we are able to understand how a magnet works or magnetic substances works. Okay, now let us learn some of the other uses regarding the magnetism chapter or regarding the magnets. We know that these magnets are used for various purposes at present. Let me cite some examples. You might have seen some magnetic strips on ATM cards or the door closers, latches, clamps, stickers. Okay, so these stickers, latches, clamps and all, okay, has got certain materials which helps to stick the things, which helps to attract magnetic substances. Magnets are again used to separate magnetic materials. You might have seen sometimes in televisions, at the time when we need to separate magnetic materials from the garbage dumps and all, you used to bring a huge magnet in contact with the garbage dump, and all the magnetic substances gets attracted to the magnet. In this way, a magnet can easily separate magnetic substances from garbage dumps and many other things. They are also used in compasses, as I have discussed that compass has got a magnet inside it, okay, which is called as magnetic compass. Magnets are even used in loudspeakers, okay, which helps in producing loud sounds at the time when musics are played. Motors you have seen that you have in your homes, generators and all, okay, also have magnets inside it. And sometimes what happens is that we also find these magnetic materials or magnets are used in storing some files or data, sounds and audiovisual signals, okay, in computers. For example, we know that in computer we need to store data or some audiovisual signals or sounds and many other things. So some kind of magnets are also used in such purposes. You might have seen the ATM cards, airline tickets, okay, or credit cards also has got some magnetic materials or special surfaces coated with magnetic material. Okay, so these special surfaces which is always remains coated with magnetic material is in computer hard disks, floppies and audiovisual and video tapes. Okay, these are some of the other uses which we have at present in the present technology. Now, my dear students, as you have learnt the uses of a magnet and you have learnt the different properties of a magnet, so let us learn how we need to store a magnet safely. So to store a magnet safely, it doesn't mean that if you have a magnet, you have to store it in your almirah or any other place. It can be stored safely. No. So to store the magnet in a proper way, we need to follow some steps. Like if you have a permanent magnet, okay, then what you need to do is that this permanent magnet, it doesn't mean that the name tells us that it has got a magnet and its magnetism will last forever. No, not like this. Even permanent magnets also loses its magnetism with the passage of time. So we need to store such permanent magnets also safely. What we need to do is that if you have a bar magnet, bar shaped size magnet, you need to put a strip. Okay, you need to put a strip of magnetic metal between its opposite poles. We know these are two poles of the magnet at opposite sides of the magnet. So we need to put a strip of magnetic metal at the opposite poles of the magnet and store it. And in case we need to store a horseshoe magnet, we need to do the same thing by putting a strip of magnetic metal at the poles of the magnet. These permanent magnets can lose its magnetism if they are hammered or if they are dropped from a very great height, okay, or if they are heated. Its magnetism can be lost, but we will never do that. We will never hammer a permanent magnet, or we will never throw it from a great height, or we will never heat the permanent magnet, because we don't want its magnetism to be lost. So what we will do is that we will try to save the magnetism of the magnet, okay, by putting strips of magnetic metal at the poles of the magnet, and we can also store such magnets in keepers. Okay, the strips of magnetic metal in which we store it is called a keepers. We can store it in keepers, and keeping it in keepers, the magnetic metal will, or the magnet will not lose its magnetism. So students, your class gets over with this. If you have any queries, please contact me every night between 8 to 10. I shall clarify your doubts. With this, I end up my class. Thank you.